Now we're here. We'll reach the equinox point at the beginning of spring next week. When the moon passes just between the Earth and the sun, the shadow of the moon falls on the Earth. This is the solar eclipse. The moon exactly covers the sun because we see the sun and moon as being the same size. In fact, the sun is immensely bigger than the moon and much farther away. But by an extraordinary coincidence, the sun, which is 400 times wider than the moon, is also 400 times farther away, so it seems to be the same size. The total eclipse is unique in the solar system. The Earth is the only place where a moon can be seen covering the sun so precisely. However, that doesn't always happen, because the Earth's orbit isn't a circle, it's an ellipse, and the moon's orbit is too. So sometimes on the day of the eclipse, we are nearer the sun and the moon is farther away from us. Then the moon can't quite cover the sun, and instead of a total eclipse, we see an eclipse in the form of a ring. If Martians existed and were interested in eclipses, they'd be disappointed. They have 2 moons, but they're too small to cover the sun. No eclipse for the Martians. Normally, there should be a solar eclipse every month because the new moon gets between the Earth and sun every month. This doesn't happen because the moon's orbit is slightly tilted and the shadow of the moon passes over or under the Earth. For the moon's shadow to fall exactly on the Earth, the moon must pass directly through the Earth-Sun axis, passing precisely on time by a point called the node. Then we have a total eclipse. Six months later, after 6 new moons, the moon is once again in line with the Earth and sun. There will again be an eclipse, but if the moon reaches the node late, it will be just a partial eclipse. The shadow of the moon will only brush the Earth, covering the sun partially. It's very rare to see a total eclipse of the sun. There are only 1 or 2 each year, and since the zone of total shadow is a narrow band, you need to be very lucky to be in the right place at the right time. Two weeks before or after this alignment, there's a lunar eclipse, because the Earth creates a giant cone of shadow in space, a shadow much bigger than the moon. So 2 weeks before or after the solar eclipse, the moon plunges into the Earth's shadow. Everyone on the night half of the Earth can watch the lunar eclipse. You see the Earth's shadow, our shadow, outlined on the full moon and darkening it. Each night, the moon appears 2 hands further to the left. So from one day to another, you can imagine the very slow movement of the moon as it crawls around the Earth. On rare occasions, we can see the moon's movement live, when the moon appears near a star. Aldebaran, for instance. Aldebaran is a distant star, but we can use it as a marker to see the moon move. The moon's crescent seems to move closer and closer to the star. Then all at once, Before the crescent reaches it, Aldebaran disappears, wiped from the sky. The star has been hidden by the unlit portion of the moon. After an hour or so, Aldebaran reappears. If you watch with binoculars, it looks like a little luminous balloon drifting away from the moon. Usually, the moon's motion as it circles the Earth is too slow to be seen. But on that night, thanks to Aldebaran, we can actually see the moon move.